This is Mr. Max with some golfer. Mathematics, it's been a while. So, for the few days, I'm going to start a sample test series for AS level learners. So, I'm going to do a test on algebra, and then I'm going to do a sample test on logarithmic and exponential functions. Okay, so it's about 30 marks, so you can see what you can expect in the examination. And then I'm going to do an AS level sample test on further trigonometry. Okay, so I'm going to drop these three today. I'm also going to do further integration. That's a sample test. So basically a bunch of questions to help you for your upcoming examinations. And then I'm going to do a sample test on numerical solutions of equations. Okay, so these are the few last chapters that you have in your AS level. Okay, so without further ado, let's look at the sample questions I have here on algebra. So you should be familiar with absolute values. Remember, this is just to guide you, for you to assist you with your revision, so to speak. So I have a few questions here, and we're going to approach them, and we're going to try to solve these type of questions together. Okay, right, so do pause the video, and then you may try to solve the questions. So the first one here says solve the inequality. So what you need to be able to be on the lookout for this particular one is, yeah, let me just bring in my pen, is when you're dealing with this type of inequality, the one that says greater than, all right? And this is going to be the same condition that you're going to apply. Remember that inequalities give you a sort of an interval rather than a single value for an answer. And inequalities where you have absolute value A is greater than B, these generally are going to be solutions for A is greater than B, or A is less than B. Okay, so on a number line, for example, this is what this particular would look like. So if that is B and that is B, in this case, it will be solutions that go in the opposite directions. Okay, so you should remember this for greater than. So the way you do this one, obviously, you are going to say 2x minus 7. Okay, we can have the first one, we can say is greater than 3, or you can say 2x minus 7 is less than 3, because we expect these two type of scenarios in our solution. Okay, so this is coming 2x is greater than 3, you add 7 here, that is 2x is greater than 5, so x would be greater than, so I see the little mistake there, just a bit too fast with my answer, so that's 10, and x is greater than 5, so that will be one condition, one solution. Okay, or I can go on here, it's 2x less than, well, you have 3 plus 7. Okay, I just want to see a little bit of something here as far as that is concerned. It should be, remember, a negative 3 here. Okay, that is what I have indicated on this side when I spoke about this type of inequalities. Okay, so this is therefore going to be 2x is less than, well, 7 minus 3, that gives you 4, and then x is less than half of that, therefore x is less than 2. Okay, so these are your two solutions. Now, what you need to do with inequalities is you need to be able to check your solutions to see if they all match up. Okay, so you put that value and then you see. So for example, if I have 2 times 5 minus 7, all right, and this is giving me 10, take away that is going to give you 3, all right, so 3 is not greater than, that answer there is not greater than, but we cannot actually use 3, we should use something that is greater than 5. So let me just find any number greater than 5, and then we see, let's think of a number. So on a number line, this would be 5 here, numbers greater than 5, and then you have got 2, okay, here, and numbers less than 2. 2 and the 5 not included. So if I was to put the 5, or let's say we take a 6, which is another number that is greater than 5, that's 12. Okay, so when you take away 7 from 12, that gives you 5. And surely the absolute value of 5 is 5, and 5 is greater than 3. So it makes then sense, and it makes it true. Okay, and the same thing will happen if you were to check for any other value. In this particular case, if we take numbers that are less than 2. So when you look at numbers less than 2, let's say we take -3, for example, and we punch that in there. Okay, so -3 by 2 is -6. -6 take away that gives you -13. All right, and the absolute value of -13 is just going to be 13. Right, and so what you do realize is, of course, if you have to go here, okay, we have got that particular one. So 13 is obviously the absolute value. The original one should be greater than, okay, greater than 3. All right, so greater than 3. So just to make sure that both solutions are working, all right, let's see if this value that we are inserting here, if it's greater than 3. Of course, the absolute value of -13 is 13, and 13 is greater than 3. So both these solutions, therefore, then will work. So this solution is going to work, and you need to make sure that you check your answers. Please, very important. It's not just about solving them, but it's also about checking your solutions. Okay, so I give you 2 inequality signs here, and you have a little bit of an anomaly, if you can call it like that. So you've got 2 absolute value signs on both sides. All right, so you may square the absolute value signs, so both sides. So that means you can say x plus 1 all square is less than 3x plus 5 all square. There's one method you can use to solve this particular, especially if you have the inequality sign on both sides, or the absolute value sign on both sides of the inequality. Okay, so I hope you still are familiar how to multiply out a binomial. Okay, so this is going to be 9x squared. Right, you can do this on the side. So it's 3x times 3x is 9x squared, and you're going to have 3x times 5 is 15. So this is going to be plus 30x and plus 25. So just make sure that you have everything. All right, so I'm just going to move all of these terms to the other side. Okay, so I'm going to have 9x squared. Then from there, I'm going to take away an x squared. All right, and then I have my 30x as it's there. And then I'm going to take away a 2x from there. Okay, so that's all of these terms, they're moving on that side basically. Okay, all right, and then I have 25 here, and now I have got a 1 that I need to take away from that. So take away 1. So at the end of the day, I'll be left with well, let's see, I have 0 here less than 8x squared, that's 9x take away 1x, and 30 take away that is 28x, okay, and 25 take away 1, well, that gives you positive 24. Right, so when you look at this inequality here, before I continue, I can actually simplify it a bit further, okay. If you simplify it a bit further, you can divide by 4, so dividing by positive 4, so this inequality sign will not change. So 4 goes here, 2x squared, 4 goes here, 7x, and 4 goes here 8 times. Okay, so 4 goes into 24 6 times. Okay, so just correct that a bit. That should be 6. Okay, a bit rusty, but we'll get there. All right, so now this is where we're at. So if you look at this inequality that we have here, this is a less than inequality. Okay, it's a less than inequality, and a less than inequality, it's going to be, when on a number line, it's going to be something that is within the intervals, like between the two numbers, like that. So I'm expecting my solution to be something like that. So you can go ahead and you can factorize this and make it an equation. We know now what we are looking at in terms of solving that. All right, but our equation is greater than, okay, if you look at that, it surely is greater than. So just want to make a little bit sure so that we do not mix our things around. Okay, so this is the inequalities. Moving everything over, you have got 0 is less than, but the whole stuff is on the left. So looking at that stuff on the left, it's going to be greater than. Okay, because if I was to rewrite this, so this we can take away. Oops. Okay, let's just go back there. So that was 2x squared plus 7x plus 6. Right, so we can rewrite this one as 2x squared plus 7x plus 6 greater than 0. Okay, that's what it means if you were to move all of those things to that side. So we are then having the same condition like we had in our previous answer. We're going to have an OR in a solution. All right, so I'm going to try to factorize. I'm going to make this an equation. So I'm going to say when you factorize this, you should get 2x plus 3. Okay. Oh, goodness. Okay. So that happened. So it's 2x plus 3. That would be one bracket, and then x plus 2. We can say equals to 0. Okay, and then you can actually solve these two equations, but remember, because of our inequality, we know exactly we need to have things that go in the opposite direction, right? Remember what I said? So you're going to have something that side and something to that side because of this condition here. Inequality here is greater than. Okay, so if you were to solve this eventually, obviously you'll get x is going to equal to minus 3 over 2, or x is going to equal to, well, that should be minus 2. Right, but the way we are looking at it is we are looking at a number that is, because you have a break in there, okay, so one answer would be, if this was a number line, and I have minus, this is minus 1.5. Now remember, minus 1.5 is very close to 0, so minus 3 over 2 will be here. And minus 2 is the smaller number. So the solution we have are values that go in this direction. So one of the solutions then would be, if I just will write it here so that you can see exactly, one of our solution would be x is less than minus 2, okay, because it goes to this direction, or x is greater than minus 3 over 2. So this would be our way of solving that particular question. Okay, right, so let's go to question 2. So this is a rather straightforward equation. You're going to let that equal to 13 for one equation, and the other equation you can say let that equal to minus 13. All right, so we're gonna find, and don't forget to check your answers. I did not check my answers here on top, but you can check your answers. Okay, so just to make sure that whatever the solutions that we have got, and we check those solutions and we go back to our original. All right, and we're going to see if you put in here the value of x's and so on, does the left side, as it say x plus 1, is it less than what is on the right? So please don't forget to do that. But I already checked, so for this ones they are okay. So both solutions would actually suffice. Okay, right, so here you're going to have nothing but x cubed minus 14. You say let it equal to 13. Okay, that would be one equation. Or x cubed minus 14 can equal to negative 13, because you can have that. All right, so this is going to be x cubed is equal to 13 plus 14, and x cubed is equal to 27, and x would be then the cube root of 27, so which means x will equal to 3. That's one solution. Or x cubed equals to minus 13, you add 14, it's 14 minus 13 is 1, so x cubed is equal to 1, so x will be nothing but the cube root of 1, x therefore is equal to 1. So now you have got these two solutions. So again, you need to be able to check these solutions, right? So I got this is an answer and that's an answer. So just to be on the safe side, you have to check your solutions. All right, so let's quickly check out and see when x equals to 3 in our equation is x cubed, right? Just to go back, minus 14. Let's see if that gives us 13. Right, so if we were to remove and we insert, in the place of x, we insert a 3. Okay, so we insert a 3. Okay, oops, let's go back. All right, these things happen. They happen. So just okay, so I had a small malfunction there. All right, so I'm back. So we said that this is now going to be 3, right? Because I am now going to substitute with that particular value there. And if you do that, you have got 27 minus 14. Well, if you take 27 minus 14, you're going to get 13. And obviously that works. Okay, right. So what if we include 1 as a solution there? All right, so when we have 1, let's just use a different color. So when we put a 1 here, well, we're going to have inside here the absolute value bracket. Okay, we are going to have 13, negative 13 to be exact. So that's going to be 1 minus 14. See, that is equal to that, and that's negative 13. And the absolute value of negative 13 is 13. So both solutions, they check out. All right, so x is equal to 1 or x is equal to 3 would definitely work, okay, for this particular equation. Okay, let's continue. So I have got a question 3 here. It's quite evolved. It says the points negative 4 comma a and 2 comma 1.75, they lie on the graph of y equals to the absolute value of x plus b. Find the possible values of the constant b and the corresponding values of the constant. Okay, so what we do is, let's use this particular point here. All right, and we are going to substitute. Remember, that's x, that's y. All right, so we're going to substitute. We're going to say 1.75, let that equal to the absolute value of 2 plus b. Okay, um, where our x is the value of. So we need to then create the two equations and we are going to solve that. All right, so this is nothing but 2 plus b, just to rewrite it nicely, 1.75. So you can say 2 plus b equals 1.75 since it's an equation, or it's 2 plus b equals to negative 1.75. Okay, right, so you can go ahead then and solve for b. Here you'll have b equals 1.75, take away 2. All right, b here will be negative, if I'm not mistaken, 1/4. Or you have b equals to negative 1.75, take away 2, that's going to give you negative 3.75. So b is negative 3.75. So we now have the values of b. So now we need to find the corresponding values of a. So we already used one point, so we are going to use the other point now in order for us to find the value of a. Okay, right, so just to make sure, x is negative 4 and our y is a, right? So I'm talking about this particular point right here. Okay, right here. Okay, so we're going to substitute that point in there. So we're going to say my y value then becomes a, and remember it was x, and what is x now? Negative 4. But here we have a value for b, and b is nothing but negative 0.25, so that would be one condition. Or another corresponding value of a would be negative 4, okay? But now we have a different value, plus, and that is negative 3.75. All right, so let's clean this up. So if you do this, it's going to be negative 4.25, so it's negative 4.25. That therefore means that a is not negative, but rather positive. Okay, remember, absolute value of something should be positive 4.25. So that's one value when b is equal to negative 2.5. A is equal to 4.25. Another one here would be, well, this is negative 7, okay, 0.75, negative 7.75. Again, the absolute value of something like that must be positive, and this is then the other conditions. When b is negative 3.75, a is 7.75, and then you can go ahead and answer it accordingly. Okay, so you can say when a equals 4.25 and b equals negative 0.25. And the other solution would be when a equals 7.75, b will equal to negative 3.75. Okay, those are the solutions then to the values of a and the values of b. All right, so let's look at question 4. So it says find the quotient when that polynomial is divided by x squared minus 4. And then you must confirm that the remainder is 7. Now there's a little bit of some work that you need to do, okay, in order for you to be able to determine that. Right, so in any case, I hope you are familiar with long division, right? So long division then, remember this is then x squared, then I'm going to have a 0x minus 4 because the x term is not there. And this one is going nicely down, x to the 4th, x cubed, x squared, x to the power 1, x to the 0. So I'm going to say then x squared plus 0x, just a placeholder, minus 4. And we're going to divide it into 6x to the 4 minus x cubed minus 26x squared plus 4x plus 15. So we are looking for that quotient, and then at the same time we have to see if the remainder is negative 7. So you can go ahead, you should be familiar on how to do long division. Okay, right, so x squared into 6x4, that's going to give you 6x squared. And then you go back and you multiply 6x squared times that gives you 6x to the power 4. 6x squared times 0x, that's just going to be 0x cubed. And 6x squared times negative 4, it's negative 24x squared. Okay, so now you can go ahead and subtract. Well, of course, if you do the subtraction, you realize that this cancel, all right, and you have a negative here, minus 0. Okay, negative minus 0, so negative take away nothing, it's just going to be negative. Okay, so this is negative x cubed, and you have minus 26 plus 24, it's minus 2x squared. And I'm going to go ahead and I'm going to bring down that 4x. Okay, so again, my negative x cubed, I'm going to divide it by x squared in order to find my answer. So my answer on top here becomes then minus x. Okay, so when you go back and you multiply back again, so you're going to say the x times the x squared, that's going to give me positive x cubed. So, and then negative x, rather it's going to give me negative times that is just going to be plus 0x squared, and a negative times a negative, that is positive 4x. Okay, let's go ahead and you know subtract. So obviously again, when you do that, you would realize that these x squares, they cancel. You have minus 2x squared, take away nothing, it's just going to be minus 2x squared. And obviously for that, it's going to be a 0. Okay, so that's 0. And I'm going to go and bring this 15 down. Okay, so that minus 2x squared must be divided again by our x squared, which will leave us with minus 2. Alright, so every time you do that, so this is minus 2 here, and now we go back again and you multiply. Alright, so when you multiply, you get negative 2 times x squared, that's minus 2x squared. Okay, let's do this. Let's go back to our pen. Okay, so that's minus 2x squared, and then you have a negative 2. With that, this is going to be 0x, and you have a negative 2 times a negative 4, that gives you positive 8. And if I go ahead and I subtract, will you realize that the x squares cancel, that cancel, 15 minus that gives you 7, and 7 is our remainder. Okay, all right, so what is our solution then to this question? Well, our solution is nothing but the quotient. Our quotient is now 6x squared minus x minus 2, as you can see on top there. Okay, so you can go ahead, you can say, therefore, our quotient is 6x squared minus x minus 2, and our remainder, we prove it to be negative, to be 7. Okay, so this one here is the quotient. Okay, let's make sure that we can write that correctly. So that's what our question wanted us to do, find the quotient and confirm, and we confirm our remainder is 7. Now they're giving us to solve the equation. So I just want to go back and write on top here how that was originally given to us. It was 6 raised to the power 6x to the power 4 minus x cubed minus 26x squared plus 4x, but then we had a plus 15 here. Okay, so clearly if you look at this 15 here, and if you were to take away 8, right, so if you were to subtract the 15 minus 8, you'll see that that 7 is the remainder. So that 7 was then taken away from that. I hope you understand that. Okay, so in a nutshell, what it means, if I give you, for those of you who don't quite get it, I'll just use a very simple technique to explain to you. Let's say you do 15 and you divide it by 4. So 4 goes in 15, well, that goes there 3 times, 9 becomes 12. And there will be a remainder. And the remainder is nothing but 3. Okay? Now, in order for you to get the 15 back, you will say 4 times 3, which is 12. And then you're going to add the remainder. Okay? And then you get that 15 like what we had here originally. Okay? But now the remainder is taken away, though. Okay, so if you take the remainder away from this, so if I was to take the remainder away, so I'm gonna get rid of the remainder. Okay, so which means I'm just gonna deal now with something quite straightforward. If there is no remainder, then it's just going to be 12 divided by 4, and it will just give me a definite answer. So when the remainder has been taken away, like in this case, the remainder has been removed because there's only a 8 that we have here. So the 7 has been taken off. So which means what we did in our previous answer without the remainder, okay, that is what we need to look at in order for us to solve this equation. So that quotient that we had there, okay, times what that divisor was, that quotient and the divisor, that is the solution. And from there, we need to solve and create or find our missing, or our, to solve the equation, okay, whatever the values of x would be. Okay, so let's just bring that back in, and maybe quickly we can look at something while I am clearly going to clean this up. Let's just continue. All right, let that not happen again. Okay, so we are going to pause. Okay, so we are back. Software is acting up today. So what I was saying, what we need to do now is we just have to go ahead and use our answer from our previous section, and we find those roots, those solutions to the equation. All right, so I hope you can still remember what was the quotient. Let's just go back. The quotient was 6x squared minus x minus 2. So it was multiplied by, so let's see, so it's 6x squared minus x minus 2, and it was multiplied by x squared minus 4 equals to 0. Well, this becomes a difference of two squares. All right, so this is x minus 2, and that would be x plus 2. Okay, and when this one here, you can go ahead and factorize it. Well, you get 3x minus 2 if you do so, and then the other one, 2x plus 1. So then you have 2x plus 1. So these are the factors. So let each of the brackets equal to 0. So you're going to say 3x minus 2 equals to 0, or 2x plus 1 equals to 0, or x minus 2 equals to 0, or x plus 2 is equal to 0. Okay, and then you are now going to solve all of them in order for you to find to solve the equation. So this is going to be 2 over 3. This is going to be x equals to negative 1/2, or x equals to 2, or x equals to negative 2. So these are then our solution to the equation. 3 marks. Okay, right, so we have got one more question here. So we have a cubic polynomial, and it's defined by that. And a is a constant, and it's given that x plus 2 is a factor. That means if x plus 2 is a factor, and using the remainder theorem, we should get 0 as an answer. Okay, so first, that is very important that we need to establish that. All right, so let me just bring in color here. So when we say x plus 2 equals to 0, then x equals to negative 2. All right, so that means that f of negative 2 should give you 0 everywhere where you have an x and you replace it by negative 2, you get a 0. So that creates then a very interesting concept. So you have negative 2 cubed plus a, then you have negative 2 squared, okay, plus 14, then you have negative 2, right, plus a plus 1. Well, this should give us 0. Okay, now when you go ahead and you clean this all up, you should get minus 8a plus, it's not actually minus 8a, it's just going to be minus 8 plus 4a. Well, I've done it before, so I should be able to get more or less what I am looking for. I think eventually it should end up with 5a is equal to 35, and then a would be 35 divided by 5. That's 7 though. Okay, so when you divide 8 by 5, that gives a to equal to, here we go again. Well, this is going to be interesting. Invalid operation. So if it's invalid, then we can get rid of that. Okay, so again, so this should be 5, therefore a is equal to 7. I think we figured out how to deal with that particular problem. Right, but this is, they say, used to find the value of a, and now we did find the value of a, but that is not what it's all cracked out to be. Okay. Oh goodness, there we go again. Well, I think we figured that one out. So we have now found the value of a, but now we have to factorize completely. So let's just put our values back. I'm just going to write it here on the side just to see what we have. Maybe I can use a different color pen. I can use black, and I'll make it a bit bigger. It's a bit too small. So we have got f of x, and that is equal to x cubed, and a is positive 7, so that will be 7x squared plus 14x plus 7 plus 1. All right, so f of x is equal to x cubed plus 7x squared plus 14x plus 8. All right, so now they expect us to factorize that. In order for me to factorize that, I need to be able to find different. Maybe I will use a long division again, or synthetic division. It's totally up to you. Okay, So I do know that if you play around with it and somehow you look for the numbers that go into 8, because there's a little bit of trial and error in order for you to do the factor theorem. Okay, so -2 is also going there. So if I replace this with -2, the objective is for me to see if I can get 0. Okay, so you can start with +2, -2, then you can go to 4. Okay, all the multiples of factors rather of 8. Okay, so well, if I was to do that and I have f of -2, everywhere where I have my x, what is it that I'm going to end up with? That is what I'm interested in. Okay, so you have -2, -2, -2. Right, so when you do input that, you should end up with a 0. Okay, just maybe to make sure that we are on the same page. All right, so I have got -2 raised to the power of 3. Okay, then I have 7. Then you have -2 squared. Then you have +14. Then you have -2 in the brackets. And then you have +8. Does it give us 0? Oh, maybe I need to go back. I think I did not add an addition here. Okay, so well, it gives me 0, therefore it works. Now, if that is the case, I can then go and say, well, -2, right? Hope you're still familiar with synthetic division. And synthetic division, remember, we take the coefficients, okay? So we're going to take the coefficient here, which is 1, the 7, the 14, and the 8. It's going nicely down, so we don't have to put a place value. So it's 1, it's 7, it's 14, and it's 8. The first thing you do is you bring that 1 down. Okay, so once you bring the 1 down, you have 1. So -2 times 1 is -2. 7 minus 2 is 5. You multiply, that's -10. And that's going to give you 4. And -2 times 4, that gives you -8. Obviously, that's going to give you 0. Okay, so that's with cubic function. So the result here should be squared, x squared plus 5x plus 4. All right, so this is the result when you have x plus 2 as a factor. I also have x squared plus 5x plus 4. Let's say equal to 0. Okay, well, they are looking for factors, so we're just going to say equals to f of x. Not really looking to solve the equation. I think it's effective. All right.